Hi, ladies and gentlemen. We are looking at notes 5.3, which are on midpoints and medians and triangles. And let's just do a refresher of what we learned in class. The first bullet that we have here is actually something new. We didn't learn the actual name of the segment in class, but we did do what it says right here. So the line segment joining the midpoints of two sides of a triangle. So I'm going to call this triangle ABC, and we're going to have a line segment that joins the two midpoints. So we're going to take the midpoint of one side and the midpoint of another side, and we are going to connect them together. And we'll call this DE. This line right here is called the mid segment. Okay, and the reason why it's called the mid segment is because it's the segment that connects your midpoints. So the line segment joining the midpoints of the two sides of a triangle is called the mid segment. Okay, so we'll say right here that this is the mid segment. And the mid segment is going to always be, if you notice right here, it will never intersect, this mid segment will never intersect my third side, which means that they are going to be parallel. And this segment right here, the size of it is always half as big as the size of the third side. So half as long, okay? And we're going to verify this using Geometers Sketchpad to make sure that our statement is really true, okay? Okay, so let's verify using Geometers Sketchpad. So what I'm going to do is I'm going to create a random triangle right here, and I'm going to find the midpoint of my two sides right here, and I'm going to connect those two sides together, and I'm going to measure to see how long this side is. I get 9.18, and I'm going to compare it to how long this bottom side is right here. So I want to verify that this mid segment right here is really truly half of this bottom segment right here, this opposite segment right here. So I'm going to take 18.36 divided by 2 and I get 9.18. So now let's see right here when if I just move it around, this time it's telling me that the bottom segment is 10.76. So I'm going to take 10.76 divide that by 2 and I get 5.38, which is what we're looking for right here. So I'm going to I'm going to calculate the ratio between the mid segment and the larger side that it's across from, and I get 0.5, which means it's a half, right? So that means that AB is half as big as CD. Now notice when I change the length of my triangle and my segments in my triangle, A, B, and CD are changing, but the ratio between them still remains the same. It's always going to be 1/2. And it doesn't matter which vertex I move around, it's always going to be 1/2. That's the answer that I always end up getting right here. It's always going to be a half, okay? Now, if A, B, and CD were parallel, they would have the same slope. So I'm going to measure the slope of AB, and it tells me it's negative 0.27. If I were to measure the slope of CD, I should get the same answer because if they're parallel, they have the same slope. So let's go ahead and see if that's true. So I'm going to measure the slope here and look at that. We get negative 0.27. If I change where my vertex is, my slopes change, and that's okay. But when I compare them to each other, they're exactly the same slope, okay? And my ratio still stays as a half, okay? So this is a little bit of a verification of what it is that we have concluded in class, and now we can see it's true using the technology, okay? All right, the next bullet, in order to figure this out, I want to actually look at Geometers Sketchpad first. But we are looking at the height of a triangle formed by the mid-segment, okay? So what we're going to do is we're going to look at the height of our triangle formed by the mid-segment. So if you look right here, this is the height of my triangle formed by the mid-segment. The triangle formed by the mid-segment is this small triangle right here, okay? I want to compare that to the height of my full triangle right here. So let's go ahead and see what happens when we do that. So if you notice right here, we have this height right here, and it's formed by my mid-segment triangle, my triangle that's formed by the mid-segment. And I'm going to measure the length of this, and it's 3.15. And then I'm going to measure the length of the height of the full large triangle. So let's go ahead and measure that. And I end up getting 6.3. And if you notice, this value is double this value, or we can say that the smaller height is half as large as the full height that we have right here. But let's verify to make sure that this is really true all the time. So I'm going to calculate the ratio between the two. So I'm going to take the larger one and I'm going to divide it by the smaller one. And if it's true, I should always get 2. So I'm going to play around with the size of my triangle. If you notice right here, these lengths again are changing, but it's the height of the larger triangle is always going to be twice as big as the height of the smaller triangle. Okay, so we're going to say right here, the height of the triangle formed by the mid-segment is half of the height of the original triangle. Okay, and then the last thing we're going to talk about is something called the median of a triangle. Now, the median of a triangle, we're going to have to draw this one out a little bit separately, a little bit differently. So the median of a triangle, essentially, what that means is the connection between, let me draw this a little bit differently right here. So the median of a triangle is going to be the connection between one vertex right here, so we'll call this A, and then to the midpoint of its opposite side. So here's the midpoint of my opposite side right here. And I want to know what's going to happen to my triangle when I draw in the median. So let's go ahead and draw an example of this in Geometers Sketchpad, and we're going to see what happens, okay? So I'm going to create another random triangle. So here's one side, here's another side, here's a third side. To find my median, I need to connect this vertex right here to the midpoint of the opposite side right here. So we're looking to see what happens to its area. So I'm going to find the area of the large triangle first, right here. And I'm going to, I have to construct the interior first. I'm going to measure the area right here. And when I measure the area, I get 56.99 square centimeters. Then I'm going to find the area of one of the smaller triangles that's created by the median right here. So let me just construct the triangular interior. Don't worry about any of that stuff. The most important thing is the actual area answer that I get here. So now I want to know what's the relationship between the larger one and the smaller one. So I'm going to calculate the larger one divided by the smaller one, and I end up getting 2. So this is telling me that the large triangle's area is twice as big as the small triangle's area, okay? And let's see right here if this is always true. So if you notice, my areas are changing size, but the relationship is still twice as big, and it doesn't matter which vertex I move around, the statement is still always going to be true. And it's true for both triangles, this one right here and the other triangle right here, because if this one is half as big as the large triangle, then the remainder is another half, so they have to be equal to each other. So how do I write this out? The median of a triangle is going to bisect its area. Now, what does the word bisect mean? Well, to bisect something, it means you're going to create 2 sections. And the sections are equal, so we'll say actually 2 equal sections. That's what it means to bisect. So in other words, to bisect, it just means to cut in half. Okay? All right, so let's apply that information to question number 1 right here. So question number 1 says find the segments below. So right here, if I tell you that ZX is 16, how big is CD? Well, first of all, I need to take into consideration the fact that C is a midpoint. How do I know that C is a midpoint? Because XC and CY are the same length. Okay, I also know that D is a midpoint, and I know that because ZD and DY are also the same length. So therefore, I can say that this is a mid-segment. And since this is a mid-segment, it's going to be half as big as that 16. So I can say that CD is equal to 16 over 2. Therefore, CD is equal to 8. Okay? All right, in part B, it tells us, again, that we have a midpoint here because these segments are congruent. We have a midpoint here at S because JS is congruent to SK. Therefore, SR is a midpoint. So I can say that KI, this length right here, is going to be twice as large as my mid-segment. So it's 2 times 5, which is 10. So I can say that KI is equal to plain and simply 10. Okay? All right. Question number 2, find LN. So I want to figure out how big this length is going to be right here. Well, first of all, I have one midpoint here because these lengths are congruent. I have another midpoint here because these lengths are congruent. So that this is a mid-segment, and I know this is going to be half as big as this. So therefore, I can say that x plus 10 is going to be equal to 2 of my mid-segments right here. And I need to double it so that they'd be equal to each other, because in order for this segment to be equal to this segment, I need 2 of these to equal 1 of these. And that's what I'm doing right here. Now I just solve my equation like I normally would. So when I distribute the 2 through, I get 2x plus 4. Subtract the x from both sides, I get 10 equals x plus 4. Subtract the 4 from both sides, and I get 6 equals x. Well, now that I know how big x is, I'm going to figure out how big ln is. Well, ln in terms of x is x plus 10, but instead of x, I'm going to replace it with 6. So I get 6 plus 10. So I get ln is equal to 16. Now I just want to check to make sure that this is right. EF is 6 plus 2, so EF would be 8, which is twice as big as, which is half as big as 16, so I know my answer here is a correct answer. Okay? All right, one more to go. If the area, number 3, if the area of triangle ABF is 16 square centimeters, so I know this is 16, I want to find the area of triangle AFC. Well, I know since right here, first of all, I didn't tell you this, but I want you guys to know right here, F is a midpoint. So since F is a midpoint, that means that AF is a median, which means that my triangle's area has been bisected, which means that this area inside of here and inside of my green triangle is the same area as the purple triangle. Therefore, I can say that the area of triangle AFC is 16 square centimeters. And then it asks me to find the area of triangle ABC. Well, triangle ABC is this large triangle on the outside right here, and it's twice as big as each one of these areas by themselves. So I can just say 16 times 2, or 16 plus 16, is 32 square centimeters. Okay, and that's how you apply the information that we learned in our stations, as well as using Geometers Sketchpad to midpoints and medians and triangles. All right, have a great day.